Hi everyone, the objective of this video is to show three different problems that are modeled as a quadratic equation. It's a quadratic model. So the first one is about a projectile. Projectile is fired from a cliff 190 feet above the water at an inclination of 45 degrees to the horizontal with a muzzle velocity of 60 feet per second. The height h of the projectile above the water is given by this equation. When you pay attention to this equation is a quadratic equation because your variable x is squared. And what is the meaning of x? X is the horizontal distance of the projectile from the face of the cliff. And then as the horizontal distance changes, and then the height of the projectile above the water also changes. So the height changes in function of the horizontal distance from the cliff. First thing that we're going to try to do is to simplify the constant that is next to the x squared, because here I see that can be simplified. I go to Desmos and I put the equation there. It gives me this decimal, but when I click here, I see that this number, this fraction, turned into negative 2 over 225, so much simplified than this one. Okay, so then I just rewrite the same equation with the simplification. And now I know that my A is negative 2 to 25, my B is 1, and my C is 190. Okay, so now I have the problem, and then I can answer a few questions. It asks, at what horizontal distance, the h is one the h, from the face of the cliff, is the height of the projectile a maximum? So as you learn from quadratic formula, when your a is negative, your parabola is upside down. It's like going down. The opening is down. And then it means that the vertex gives you the maximum values for that parabola. So when I want the horizontal distance from the face of the cliff, at what horizontal distance from the face of the cliff is the height of the projectile maximum? So I want to find the x that makes my h the maximum. So then what I have to do, I have to find the x coordinate of the vertex. How do I do that? I do negative b over 2a. I replace the b with 1, the a with negative 2 over 25. Here on the denominator I multiply. And then so this is the inverse. Né? So 1 divided by 4 is 1 that multiplied to 22.5 over 4 feet. So it means that when, and what is this 225 divided by 4? This is simplified. I will answer like that as a reduced fraction. But in terms of the number itself, I just go there by curiosity and see that 225 divided by 4 represents the 56 feet and a fourth, 0.25. So just that I know that. So when it's about 56 feet, the projectile, the distance from the cliff, you'll be on the maximum height. Now the second thing, what is this maximum height? Then now I know what is the x that will make the maximum height. I will replace x into the function, find the y coordinate of the vertex. Né? So I will do replace x by this number here, and then I get, so I also put this on decimals, this whole expression, and I check as a fraction, and this is the number that I found, 1,745 over 8. And then I went there, try to see what is this value, 218 feet, 125 thousandths. Okay, so it starts 190 feet and went to maximum of 218 feet approximately. So it's how high that projectile went. And then after that, because of the gravity, the projectile will gonna start going down. Now I'm gonna use a graph utility. I'm gonna graph this function h, and I will show you a set. So I'm gonna use the settings because it tells me you have to read the whole thing. Use a graph to graph the h on this interval, and the graph also has to go from 0 to 220 for the x, and 0 to 204 for y, and the tick, the interval for the x, this is the meaning of it. I'm gonna do intervals of 20 for the x and intervals of 50 for the y. My y is the height. So let's go to so here it is. I typed the function, the quadratic function, but when I plot, it didn't show like that. So I came here to the settings and I followed that settings. So the x should be from 0 to 220. I put -5 that I could see the edges here around 0. And the same thing for the y. It told me that the interval is from -5 to 240 for here. I label that my horizontal line, that's my x. It represents the distance from the cliff. And my y represents the height in relation to the water, right? So when the projectile was launched, was on the height of 190 from the cliff, and then it's right here. So if I click here, I see this point 0.9. When the projectile was on top of the cliff and was launched, the height of the cliff was 190. And then we learned that the vertex, or the maximum that the projectile went upwards, was 218 feet. From 190 went to 118, and the distance, and you start to get distant from the cliff. Now it's not on 0 anymore. It's not on top of the cliff, but a distance of 56 feet from the cliff, in a height of 218 in relation to the water. And this is the information that you have to have. And then now it is asking you to use decimals or other graph utility and decide which one of these is the correct, which one of these graphs is the correct answer. As we notice that when you put the interval from 0 to 240, you see that reach here at this last tick, on this last interval. And then so this one did not even reach the water on this point. Here it hit the water way earlier, and here it was not on the last interval, but one before. So let's see this again. See, it hit the water. How do I know that hit the water? Because the height is 0. and the height represent the height in relation to the water. Probably this cliff was in the ocean or something, and eventually would fall into the water. Okay, so this would be the right answer. This that you have to pay attention. Next question. At what horizontal distance from the face of the cliff will the projectile strike the water? This that they want to know. Water, so when the projectile strikes the water, then h is equal 0. So then I can do two ways. I can solve this equation, set h to 0, and then solve this equation using quadratic formula, or find the x-coordinated on the graph when h equals 0. So when you have a more complex, so you could do both ways. Present this because, again, you're using calculators. This will not be difficult to put this in a formula, in a quadratic formula, and find the value for x. Or you can come here and you see that the point where height is 0 is when, so this means that the projectile will, when the projectile will hit the water, this projectile will be 212 feet away from the cliff. And this is what they want. And then, so if they ask you to round to the whole number, to a whole number, you'd approximately you'd answer as 213 feet. You have to pay attention how they want you to. For example, if you were in a military thing, you would use the whole number because this would make a difference to go and search for this projectile, to recover the projectile. So, but for our calculation, the first, okay, round to the whole number, the first whole number, and then so you become 213 feet. So here you have to explain what you have to do to find the horizontal distance when the projectile strikes the water. Is when h is 0. And then I could solve this as a quadratic equation or go to Desmos after I graph and explain that for the value of the x-coordinated when h is 0 is the value of 212, and then you have to round if this is asking to round. Okay, last question. When the length of the projectile is 100 feet above the water, how far is it from the cliff? So what you have to do here, now you have to explain. It's okay, for me to find this, when the projectile is 100 feet above the water, then my h is 100. And then I have to solve this equation. Now instead of 0, I have 100 here. Or go to find the x-coordinate that can be found on the graph when the h is 100. So let's go do that. So on here, it is difficult. For example, I can, you know that you can click on the thing and it start going. So I want to find 100. And then I get here. The h is the second coordinate. The second coordinate of the order pair. Here's 99, here's 99, 98, so I have to go a little up. Then I get here. I never get the 100. So how do I use Desmos to find the 100? First, I mark a horizontal line. A horizontal line is always represented by y equal number. And I want to be 100, is the height. And then when I click here, I see a point of interest. That's the point of intersection between the parabola and the line. So then I mark this point. I saw what number was here and I marked the point. And now I see that when the projectile is 100 feet from the water is already in a distance of 171 feet from the base of the cliff. And this number again, it may ask to round or not, and then you have to go from, decide to do this or not, the rounding, based on how they want you to answer. Okay, how could you show me that? Because I want to know how you found this. And then so you can just, you're playing with decimals, but then on your worksheet, you can draw, it's okay, I used the decimals, and this is what I did. And then so you kind of draft doesn't need to be precise, but has to represent something like that, the X and the Y, and then what each one means, and then how you found this point. And the same thing here, how you found this point, and then where it would hit there on this point. Okay, I am fine using decimals in the case when solving the. Okay, so now this is it. On this part here, I will present a problem in business that is also modeled as a quadratic equation. So let's read here. The price P in dollars and the quantity X sold of a certain product satisfy the demand equation. X equal negative 6P plus 600. Then so it's very clear that first, how do you find how a business find the demand equation? So the demand equation here in this case is modeled by a linear equation. And then so is by collecting data throughout the time per year, for a year, or it depends what is the business. They collect the data and then they create a linear model between the quantity sold and the price. And this is how they got this demand equation. And so this is the demand equation is a linear equation. But let's see what they are asking. You're going to use this information here and find the model for the revenue as a function of P, of the price. And then another concept that you must know is the law of demand. What is the revenue? Revenue is calculated by the amount of product that you sell times the price per each one. When you multiply those two numbers, you get how much money enter in your business. So you start with the law of demand, and you will replace what? This equation says that the quantity is given by this expression, then you replace X by this expression, negative 6P plus 600. And when you apply the distributive property of multiplication, you get that the revenue is represented by a quadratic equation. So the revenue is a function of P in a quadratic equation. All right, so this is your model. You express the model. Now they're asking, what is the domain of the revenue? So revenue is always the money that entered into the business by selling a product with a certain price. And then, so the revenue is always non-negative, can be zero, that you didn't sell anything, or a positive number. So you're gonna start with the revenue. And so this whole thing has to be positive. The revenue is non-negative. What I did here, I start with this expression and already put the P, factor out the P. So basically I start with here, because I factor out the P. And this has to be positive, greater, has to be non-negative, so greater or equal 0. And then I find what P can be, what is the possible values for P. The price also is a non-negative number. So the P here, you know that is non-negative. So it means that this also must be greater than 0, because when you multiply both, it has to continue being greater or equal 0. Now you solve this inequality. So you subtract 600 on both sides, and you divide by -6 on both sides. Pay attention when you multiply, you divide by a negative in an inequality, you have to invert the inequality sign. So it means that the price is greater or equal 0 and has to be less than equal 100. So the domain for this revenue function is only prices between 0 and 100. That is valid, okay? Anything beyond 100 or negative is not possible, or beyond 100 is not valid. Anything, if you price for this business a product above 100 is outside the domain. Okay, next analysis. What price P maximizes the revenue? So again, you learn from the property of a quadratic equation that when the constant that is multiplying the square is negative, it means that your parabola is open downward. And then we are talking about a maximum point, that's the vertex of this parabola. When I'm trying to find the price P that maximizes the revenue, I'm saying that I'm trying to find the P coordinate of the vertex, or the P coordinate in this case is the row of the X. So then I know that the price will be negative B over 2A, the B is 600, the A is -6, I replace here and I get $50. So the $50 you maximize my revenue, maximize the revenue for this business. And what is this revenue, this maximum revenue? Then now I find what? The revenue coordinated of the vertex. That is replacing the $50 here, and I will find what is the revenue. Will be $15,000 per example. Okay, so when you sell your product by $50, you can get the maximum of $15,000. This is the max of revenue that you get. Nothing more than that. How many units are sold at this price? Remember that you start with the demand equation. The demand equation is the only one that contains the quantity sold. So you're going to use the demand equation, replace the price by 50, and obtain the amount of products sold. So pay attention to this. So the maximum revenue that you obtain is when you sell your product for $50, and you have to sell about 300 of this product. And these all take in consideration that you did the analysis prior with the demand equation. Okay, now what price should the company charge the product to earn at least $12,096 in revenue? So to do that, what you have to do. So now the revenue has to be, they want at least 12,000. Let's start then, set the equation equal 12,600 and see what is the possible values of P to sell this product. First I replace, so RP is 12,096, and then I see that all these coefficients are divisible by -6. So I divide everything by -6, and then this became P squared minus 600. Here would be negative, but then I passed to the left side, became positive, 2016. Set to 0. I can solve this. I can see that, for example, if you're not very good in factorization, you use the quadratic form. But this equation can be factored. And the two numbers that the product is, that the sum is negative 600, 100 is those two numbers. And when I multiply, gives these numbers, these two numbers. And, or if you use quadratic formula, you're gonna find 2p's as well, the same. That is the number 28 and the number 72. So you found two prices that will make the revenue exactly $12,900. $12,960. It's not 106, it's $96. $12,096. And but they don't want exactly just the exactly value of revenue. They want at least 12,096. So it means it can be 13,000, can be 14,000, can be 14,500, up to 15,000, because this is the max that's possible. And then what are those values? And then so for this, we're gonna use decimals. And then pay attention to that. So I wrote my revenue function here, and I got this parabola that was expected upside down. And I know that the vertex is the $50 with 15,000 revenue, the price of $50 per product. And now I want to know, I will draw a horizontal line on the new revenue that I am focused on. That's the $12,096. And here is the horizontal line. And the horizontal line cross the parabola in 2 points. That's what you found, 28 and $72. But then anything between those values is more than the 12,096. If you go 12,000, and then you get here to the max. So you can sell a little more than 72, you get $50. But anytime that you sell above $50, you don't get the same revenue, because people might think that this is too expensive and then they buy less. So it exists an ideal price and prices that you are satisfied to sell for is between those two. So any price between 28 and 72 will make at least this amount of revenue. And then my final answer, you will see that the graphs intercept on these points, exactly these points. Then the revenue will be at least 12 when the price of the product is between $28 and 72. So any price between 28 and 72 will satisfy this revenue. This is an example of a quadratic model in geometry. Let's read. Diana has available 520 yards of fencing and wishes to enclose a rectangular area. Let's see what you can create from this statement. Use this information and express the area of the rectangle as a function of the width, given by the letter W of the rectangle. So let's make some geometric drawings. We are talking about a rectangle, and the rectangle has two parallel sides, four sides with two parallel to each other with the same length, same size. So then I call this the length, and this is also L. If I call this the width with W, then this is also W. When we are talking about a fencing, it's because we're gonna fence around this rectangle. And you're gonna think geometrically that this corresponds to the perimeter. So 520 yards is the perimeter for this rectangle, where perimeter is given by the sum of the size of each size. And then we have that the perimeter is 2 times the length plus 2 times the width. Why 2 times? Because we have a length here and a length here. Then length plus length is 2 length. And then we have a W here, 2 W's. So there is not much to memorize here in terms of formula. Is to learn what is the concept of perimeter, and also that's the sum of the size of each side. And I will use this and obtain that 2L's plus 2W's is 520, because this is the amount of fencing that she has, Diana has. I see that each coefficient is even, and I can divide everything by 2. Now I have that, and then I write the length in the function of the W. Why? Because I want to express the area of the rectangle as a function of the W. If it says that was for the L, and then I would write W in the function of L, but not the case here. So I have L as 206 minus W. How do I find the area of a rectangle? The area is the space inside the rectangle, and then so is given by multiplying the width times the length. But the length, like we saw here, can be replaced by 260 minus W. When I apply distributive property, I get this as area as a function of the width of the rectangle, the way it was asked. Then I'm done. So observe again that the area of this rectangle is represented by a quadratic equation. The quadratic equation has the main coefficient as negative, so the parabola will be downward, and because of that, it have its apex. It so has this max, the max that is the vertex. So you already draw these properties from observing this function. Now let's see second, what can we explore here? What is the value of W that gives the largest? Is by finding then the W coordinate of this vertex. And is minus B over 2A. And then you replace the value for B to 60, the value for A, that's -1, and you have 130 yards. If the width is 130 yards, she will have the largest area possible. And then now, what is the dimension of this area? Now I will replace the value of W in the function by finding the A coordinate of the vertex. I replace by 130, and I have that she will have 16,900 square yards of area after she fences this rectangle. I want you to observe something here. So now we're done. So the best way for her to use her 520 yards that she has available is by making a rectangle where the width is 130. But if the width is 130, then the length is also 130. And then observe that the maximum area of a rectangle is when this rectangle is really a square. It's when she will obtain the maximum area. Maybe she's trying to make a garden and make a fence around to avoid the prey, the rabbits and other things. And then, so what's the best way to build? Is as a square. So that's